You ever stop to think about the invisible highways of electricity that are literally all around us? They're in your walls, your car, your phone, they're everywhere. But what happens when one of those invisible paths gets a crack in it? Well, today, we're making the invisible visible. We're diving into something called electrical continuity. It's a super simple but absolutely vital test that makes sure power gets exactly where it's supposed to go. So, picture this. Your favorite gadget just won't turn on. Or maybe a light in your house just went dark. You look at the cord, the wire, it looks totally fine from the outside. But is it broken on the inside? That's the big mystery we're going to solve today. How do you find a break that you can't even see? Well, the answer is way simpler than you might think, and it usually comes with a pretty satisfying little beep. All right, here's the game plan for this explainer. We're going to start with the absolute basics. What even is electrical continuity? Then we'll get into the science of that beep. After that, we'll look at where you see this stuff in the real world, from tiny gadgets to massive buildings, why it's actually required by law, and finally, the tools you'd use to do the job. Okay, first things first. What in the world is electrical continuity? You know, the easiest way to think about it is like a garden hose. If there are no kinks, no holes, no blockages, the water flows right through, no problem. Well, electricity works a lot like that. And a continuity test is basically just our way of checking to make sure the hose, or, the wire, is totally clear. So if we want to get a little more technical, here's the official definition. But really, there are only two phrases you need to remember: uninterrupted path and low electrical resistance. All we're really doing is checking for a clear, easy road for electricity to travel from point A to point B with zero roadblocks along the way. Yeah, this really boils it down to just two states, right? You've got a good path, which is a closed circuit. Think of it like a brand new, perfectly paved superhighway for electricity. The resistance is super low and the current just flows. But a broken path? That's an open circuit. The resistance is basically infinite. It's a dead end. The bridge is out and the current is totally blocked. Okay, so let's get into the cool part. How does that little handheld gadget actually know the difference? And how does it make that beep? It's not magic. It all comes down to some really simple, kind of elegant physics. So your tester, it's not sending some huge jolt of power down the line. No, it just sends a tiny, totally safe little signal through the wire. It's basically asking, hey, how tough is it to get from one end to the other? And by measuring the resistance, or the pushback that it gets, it knows the answer almost instantly. So how do you actually do one of these tests? It's really just 3 steps. Step 1, and this is the big one, it is absolutely non-negotiable for safety. You have to make sure the power is completely off. You can't test a live circuit. Step 2, you just touch the tester's probes to each end of the wire or path you're checking. And step 3, you get your result. If you hear a beep, you've got a good, complete path. If the screen says OL, which just stands for open loop, or sometimes just the number 1, that means you found a break in the line. Okay, so we know what continuity is, and we know how to test for it. But why does this super simple test matter so much? Well, as it turns out, it's absolutely critical in a huge range of real-world situations. I mean it, this simple test is kind of a superhero in disguise. Technicians use it all the time for fault finding, hunting down that one bad wire in a super complex machine. Manufacturers use it for quality control on literally everything from cars to computers. But maybe most importantly, electricians use it for safety checks to make sure your home's grounding system is solid. That's the wire that gives a dangerous surge a safe path to the earth, protecting you and your family. Heck, people even use it to figure out how old mysterious circuit boards were designed. And get this isn't just a good idea for technicians to do. A lot of the time, it's actually the law. This test is so fundamental to electrical safety that it is written directly into regulations all over the globe. I mean, just take a look at this quote from the British Wiring Regulations. It's pretty clear, right? What it's saying is that before any new electrical system can even be switched on, an electrician has to prove that the safety wires, those protective conductors, have a solid, unbroken path to the earth. It's a foundational step to prevent really dangerous electrical shocks. And this isn't just a UK thing, not by a long shot. Big global bodies like the IEC, that's the International Electrotechnical Commission, and OSHA over in the US, they have very similar requirements. The major takeaway here is that proving continuity isn't just a best practice. It's a cornerstone of electrical safety, recognized worldwide. So, what do you actually use to perform these super important checks?
Let's wrap things up by looking at the tools of the trade, which range from the really simple to the seriously high-tech.
So, on the most common level, you've got your digital multimeter. This is like the Swiss Army knife for anybody who works with electronics. For just quick checks, there are dedicated testers that just give you a simple pass or fail. But what if you're building, say, a modern car that has thousands of wires? That's where automated analyzers come in. They can test hundreds of connections in a matter of seconds. And for those really annoying problems, like a connection that only breaks when you wiggle a cable just right, they have special latching testers that are designed to catch that super brief fault.
And if you're ever curious about who actually makes these tools, you'll see a few big names pop up over and over again, like Fluke, Megger, and Cirrus. These are some of the companies that build the professional-grade gear that keeps our electrical world humming along safely and reliably. So the next time you flip a switch, or you plug in your phone, or even just walk through a modern building, just take a second. That simple principle of continuity, confirmed by a humble little beep from a tester, is the invisible guard that's making sure electricity stays on its path, powering your world and, most importantly, keeping you safe. Makes you wonder, what other unseen connections are at work all around us, every single day?